Well, welcome, friends, to yet another TTI live session. I'm so excited to be back with you. It's been a minute. There have been some changes in my own work schedule, which mean that hopefully this can become a more frequent thing. I'm really excited for that to be true. And don't quote me on this, but maybe, just maybe, doing some more Twitch in the not too distant future. Anyway, today we're here to talk about Caddy, which is my favorite HTTP web server. And I've kind of bent it to my will in a bunch of different ways. And today we're going to talk about how it works and some of the cool things you can do with it. I'm basically going to show you a collection of tricks. But to start, what is Caddy? It's an HTTP server written in Go. I know it's written in Go, yet I'm interested in it. I forgot to hit start streaming on OBS. Oh, but I'm recording. That's okay. I'll upload it later. So it's written in Go, and even though it's written in Go, I like it a lot. And it's an HTTP server like Apache or Nginx, so its job is to host web content, but it can also function like Nginx as a load balancer or a reverse proxy. What sets it apart from those other tools is its ease of configuration. As we'll see, the syntax for the Caddy file is so clean and so easy to remember that it makes it really versatile as a tool. In addition to that, it has some pretty easy command line options that make it a really nice go-to for like when you just need a web server. And it has some niceties that the trusty Python HTTP server module does not have, which I've found really useful in my day-to-day life. So, fastest Caddy intro ever. Okay, this is it. This is all I had planned, just this slide. We're going to deploy a static HTML website to alfarts.zip with an auto renew let's encrypt cert. Once we have Caddy installed, all we need to do is set this up as the Caddy file in etc Caddy, and the file is literally called Caddyfile, as we'll see. This is the entire config. It is the URL that you're going to use with the HTTPS scheme that tells Caddy to set up Let's Encrypt by default and get the cert and keep it renewed. You tell it where the web root is for static sites, and you say file server to say go fetch files there. And that's it. That's it. As long as there's an index.html there, you're done. There's no other file, I should mention. There's no like nginx.conf and then this is in sites available. This is the entirety of the Caddy config. That ease of use really made me fall in love with Caddy, and its ability to do all of these other things made me love it even more. Now, inside the Caddy file, as you'll see, we can also define multiple sites, and there are different ways of defining sites. I have a bunch of code for you. If you go to, and I'll copy this into the chat, if you go to codeberg.org/the Taggart Institute Caddy Intro, you will find the code for today's demo. It is made of a handful of Podman Compose, Docker Compose files that will set up Caddy servers in different configurations for you to test out. I've really come around on using Podman as sort of a deployment way to do this. It makes it really, really easy. If you have Podman installed, that'll work fine. If you have Docker installed, it'll work fine too. So let's start with getting Caddy. Now, for all of the demos in the repository that I just shared with you, the containers will have Caddy installed. You don't need to worry about that. But if you want to use Caddy on your system, especially the CLI tools, which we're about to demo, you're going to want to install Caddy. Or if you plan on using this in real life, how do you install it? The most important thing you need to know, especially on Ubuntu systems, do not use the Linux system packages. They are too dang old. And even Fedora is a little bit behind. I think the latest version on GitHub is 2.10.2, and Fedora 42 is up to 2.10. So not so bad. But if you want the latest and greatest, and you do most of the time because Caddy development is pretty active, head over to GitHub and grab the appropriate binary from the releases page. Now, when you install it in this way, it will install as a systemd service, but I should say not binary package, because there are RPM and deb packages as well as straight ahead binaries. But when you install the OS package, it installs as a systemd service as well as a CLI callable tool. The systemd service will run as the user caddy, and that does matter when you're pointing at different folders because you need to be aware of who owns it, right? Because only the user caddy will be able to access anything that you're pointing it to. All right, let's have some fun with the Caddy CLI. So there are a few commands that you want to know about. So caddy run will just run a local caddy file that it is in the same directory as you're running the command. And then we'll play with all of these, but Caddy file server runs a file server with a built-in browser. I love this one. I'm going to show this one to you first. And it should be not super hander. That should say super handy for data transfer exfil. And then Caddy reverse proxy. If for whatever reason you need a right away reverse proxy, one that does HTTPS, you can just do this and it'll spin it up automatically. It's not meant for production use. I mean, it's production grade, but the command line usage isn't meant for in production usage. You should set that up as a service and do it the correct way. But this would be sort of like a network plumbing sort of situation, or if you're a red teamer, data exfiltration, all sorts of interesting things. You could even imagine it as part of a pivoting technique. Let me go over to our terminal here. How's the text size on the terminal? Do I need to go bigger? Good for me. Some might not like it. There. Now we should be in good shape. All right, so I'm gonna quickly spin up a Caddy file here that isn't in the Caddy intro because this is just raw. It's outside of the demos. And I'm gonna say port HTTP localhost and say 8888. And then we'll do respond, which we haven't talked about anywhere else. Hi from Caddy. All right, so now I'm gonna pop open two panes here so I can run curl. And then on the left-hand side, I'm gonna do Caddy run. And on the right-hand side, I'm gonna go curl localhost 8888. Web server. Now, if I wanted to do something more interesting, I certainly can do that. So, for example, let me kill Caddy over here with Control C. Now let's modify that Caddy file. Instead of respond, I will say file server. And I will also, so I'll save that, and then I will open an index.html, and I'll say hi from Caddy. Okay. If you like the text editor I'm using, that's Helix, which we did an intro on in our last live session. You can go find that on YouTube as well. So now when I do Caddy run, and I do curl localhost, I get the index.html, which Caddy automatically went and looked for because I gave it the file server directive. Okay. Control C. So that's Caddy run. And I'll do one more with this file server, and then I'm going to give it an extra detail inside the file server directive, which is the browse option. And then I'm going to remove my index.html. I'm again going to do Caddy run, but this time I'm going to go in my browser to localhost 8888. Behold, Caddy comes built in with a file browser that is like nice and searchable. And so if you point it to a directory, and it is directory scoped, like I can't go up outside of this, but it's directory scoped. So if I wanted to have like really easy data exfil, notice that a bunch of these have index.htmls in them, so it'll take you to the index. But for the ones that don't, it'll just show you the files and you can just straight download. Again, very handy for those times when you just need to get a file from one place to another. Maybe you want it to be a little bit cleaner. Maybe you want it to be a little bit easier than Python. Maybe Python's not installed. Although that's pretty rare these days, huh? Okay, now that is with the Caddyfile, but in order to do that same thing, you don't even have to work that hard because Caddy has the file server command, and you can do the same thing with -L for the listen, which is host port, and -B for browse, and it does the exact same thing. I'll reload the page just to prove that point. Page reloaded, and exactly the same thing. So you have a command line option to do that. You don't even need a Caddy file in that case to make that file browser thing happen. Caddy reverse proxy is like a lot. Yes, I'm aware of Python HTTP server. The point is that this is another tool that has more capabilities than that and in addition to that. Yeah, I mentioned the Python server like 5 times before we got here. Specifically so we wouldn't deal with that kind of a thing. Okay, so let's move on from the CLI because while cool, it's really kind of a minor component of what you do with Caddy. And instead, let's go into some of our demos. Close this. Excuse me. Okay, so actually before we do that, let's talk a little bit more about the Caddyfile syntax. There are essentially 2 parts to the Caddyfile syntax. The first is the global options. And actually, this is wrong. There should be an additional set of curly braces at the beginning and end up here. And then there's the logging option. But the global options come up here, and then there is a per site config. And it's essentially like directive and then arguments. And then sometimes the directives take blocks of additional configuration. If you want to learn everything there is about the Caddy server function and the Caddy file in particular, you want to live in the documentation for a little bit. It's very, very good. But you do have to spend some time, especially in the directives section, learning everything you can do inside of a site config. There's file server, right? There's also handling for specific paths, log configuration. Yes, it can do PHP, by the way. PHP is not one of the demos today, but I am not muted. And I don't think my... Okay. Caddy can do PHP. It's not one of the demos today, but it is very simple to make Caddy a front for PHP. In fact, if you go to common patterns in the documentation, that's it. If you have PHP FPM installed, it's really, really easy. As long as PHP FPM is set to a port, not a socket, then that's it. You're just essentially forwarding it over to that port. You can also do it to a socket, as you can see there. You just have to be aware of whatever that is. So in a way, not in a way, it literally is easier to set up PHP with Caddy than it is with Nginx, which I've always found to be a bit of a pain. And then everything else is about the PHP modules that you have installed. I have deployed PHP with Caddy and just like running on Alpine. So it's super, super lightweight and done it for like WordPress and other PHP applications. It works just fine. A couple of details or gotchas. The way that you define the site in the beginning of the site block has a lot of implications for what Caddy is going to do under the hood for automatic configuration. So let's take a look at those address patterns really quickly, just so you're aware of them and what they'll do. And I'll zoom this in so it's easier to see. So if you have just a domain name without a scheme, it's going to automatically try to do HTTPS with a publicly trusted certificate, meaning it's going to go after Let's Encrypt by default to get the cert. So that won't work inside of like a local network without a public accessible interface. The same is true with the star dot, right, which is a wildcard. Now, if you do localhost, then it's going to use its internal CA to create a locally trusted certificate. With HTTP, adjust the scheme. It's going to do every HTTP, anything that you access over HTTP. Same with HTTPS. But if you do something like HTTPS and then localhost and then a port, it's going to do the self-signed, which is a little bit easier. So it can do self-signed certs, but you have to be aware of how you're defining your site, and this will impact the way that Caddy sets itself up. Questions on this section, because this part is like one of the easiest ways to start falling into traps with Caddy, because these rules are like non-obvious. All right. So some other details or gotchas, right? So default HTTP, HTTPS ports can be changed. You can default them to other ports, but are going to be 80 and 443 respectively. And self-signed certs work for host names only, but not for ports, right? Oh, thank you for asking that question. Yes, any mechanism for default HTTPS direction. There it is right there. It is automatic. That is a default that is on. If you have an HTTPS site configured and you access the Caddy server over port 80, it will serve on port 80 and immediately redirect you to HTTPS. That is the default. You can turn that off in the global config, but it is the default. So you take no action to make that happen. Another thing that I like over Nginx, right? How many times have we done the 80 listener to just do a 302 or 301 to HTTPS? You don't have to do that with Caddy. Caddy knew that you were coming with that one. All right, into our demos. Demo 0, a simple HTTP. So Caddy doesn't have to do HTTPS. This is the most simple, the most elementary of Caddy demos. All right, so we'll go into 0, HTTP. Let's take a look at the directory layout here, just so you understand what we have. We have a Docker compose, an index.html, and a config folder, and inside of the config folder is simply the Caddy file. So we're going to take a look at the Caddy file first and work our way up from there. If we config Caddy file, that's it. And as you can see, it's a default port 80, so it's a catch-all, everything on port 80. And we're pointing it to a root. This is the web root of user share Caddy, and we're saying you're a file server. So static site is what that means. Why is it user share Caddy? Because that is the default location for where you put stuff inside the Caddy Docker image. And so I just have Caddy 0 here. The image is Caddy latest. And then I'm just mounting my index.html into that location and then pointing the config folder at etc caddy so that the Caddy binary and the entry point for the container is getting the right config. That's literally it. And then forwarding port 8080 in this case. Right? So if you want to bring this up, all you'd have to do is podman compose up. And I would do -D. Apparently I have to pull the Caddy image, which is fine. Okay. And then if I curl localhost 8080, there's hello from Caddy. Bring it down with podman compose down. That's it. Docker compose, of course, works as well. That one was quick. Any questions on simple HTTP? Caddy, the HTTP one's pretty simple. Yep. Okay, so the value proposition, maybe the value proposition of Caddy is that you get HTTPS with no pain and no effort, right? So let's actually look at what that entails. So in demo one, we're going to talk about an self-signed HTTPS. So how do we do it with an internal cert? So we're talking about like something on a local network. You don't have a public IP address, but you want HTTPS. You want a cert for it just so that it's an encrypted connection. How do you make that happen with Caddy? Well, instead of running OpenSSL commands to create a self-signed cert, Caddy has its own internal CA that it will handle for you. And you can, if you want, install the root, but honestly, don't do that. We'll talk about how to handle proper signed certs in a second. So again, if we look at the config and Caddyfile, the only two differences is we've changed this over to HTTPS and localhost so that I'm specifying like, hey, this is localhost, give me a self-signed cert for localhost, but don't try to go to Let's Encrypt. Remember those patterns that we saw for the site name. And the other thing I put in there was a header for server, not Caddy, just to show you that we can add headers. Okay, same deal. We're gonna podman compose up. And for this one, I'm going to go to the browser. And I believe it's localhost 8443. Yep. Okay. So you can see that I get your connection is not private. Vivaldi or Chrome or whatever is going to yell at me appropriately. And of course, we know that this is unsafe. Bypass for that. But let's examine the certificate so we know what we're looking at here. So you can see that it's the Caddy Local Authority ECC Intermediate. This is the default CN for Caddy's internal cert, which can be changed, and we'll see how to do that in later demos. And then, of course, you've got your local host, and it is just localhost, right? Ain't no sans or anything like that in there. If you wanted to have a certificate for both, how could you pull that off? You could comma separate like localhost and 127.0.0.1 in your site config. Oh, there was something else that I wanted to show you here. Oh, yeah, right. So if we open the dev tools and go to network, let me reload this, and we just quickly take a look at the headers, you will see, it's a little small, but you'll see there's my server of not Caddy. So that's being set appropriately. Okay. Questions on self-signed HTTPS? Nothing too complex just yet. Things get more fun in the next one. Okay. Our next demo is going to be for a custom CA. So this is where you have a certificate authority inside your PKI and you want to use that root as the signer for certificates in your environment. So what happens in that case is that Caddy essentially becomes an intermediate for that. You can absolutely do that. And I've put together just a easy make ca.sh for you, simply to make it painless to run OpenSSL commands. But if you know what you're doing with OpenSSL, feel free to make those certs as well. What we're going to do is over in the CA folder, right? There's a ca.conf, which feel free to modify that. So this is the OpenSSL config file. This is much easier to use than all command line options for OpenSSL. You can point it at this config file and then you're done, right? In terms of how you make the thing. Modify these values to your heart's content. Doesn't really matter. This is what I've set up, but it doesn't, again, matter for our demo. And then for the make ca.sh, what is that doing? It's literally just doing an OpenSSL command that is really long and annoying, right? So we create a new key, 4096 bits. We set it to output to CA key and create the output to CA cert, set it to 10 years, like a good old root CA. We do not encrypt it. This, by the way, this node-des is deprecated. It should be no enc anymore. And then we pointed at the config of ca.conf to get its options. That's it. And now I have my certificates. Obviously, I did not want to put those certificates and keys into the repo. I wanted you to have your own. And that's just good practice. Don't put private keys in Git repos. Now that those keys are available, let's take a look at what we have in 2. So here, if we go into the config Caddyfile, a bunch of new stuff is happening. In the global options section, you'll see that we have a PKI block in which we define a certificate authority, which I'm calling TTI, and you can call it whatever you want. The intermediate CN, which is the one that you're going to see on the Caddy cert, is called TTI intermediate. The root then is for a format of PEM file, and then we point it to the cert and key. This CA directory is mounted by the compose file. So what we're doing is we're going to become an intermediate, and we're going to create certs that are issued by our intermediate, but that the upstream trust is provided by our root. Now, be aware that by default, Caddy's certificates will not include the root. So if you want in this form, right, it works, but just be aware that there's like a bit of a difference. And then lastly, we have the site config where we have root and then we point the web root. That's all the same. The difference here is the TLS block where we have an issuer called internal, meaning not ACME, meaning not let's encrypt, right? And we point it to the CA of TTI, saying go get this. So it's kind of looking at itself for the certificate. So let's see what happens when we do this. We'll bring this one up. Oh, I forgot -D, but that's okay. Actually not bad, because now we're seeing how Caddy logging looks. And notice that you have this certificate obtained successfully, right? Yeah, that looks good. And then this is important. Look at the issuer, TTI. You super want to make sure that that's true. Otherwise, if you mess something up in there, Caddy will be like, I'll just use my internal local and not the one called TTI. The default internal issuer is called local. All right, so now if we reload our 8443, We get another cert error. But now let's take a look at the certificate. Behold, you have a TTI intermediate that is present here. And it does not contain the root. If you want it to contain the root CA as part of the chain, what you basically need to do is you need to, well, one of two things. Either produce the intermediate manually with your PKI, and you can create an intermediate CA, you can create an intermediate in PKI. Let's try that whole sentence again. You can create an intermediate in Caddy the same way that you created the root. So if we go into Caddyfile directives and we go, it would be global options, and we go to PKI, you'll see that there's an intermediate option that looks exactly like the root, and that will allow you to point one at the other. The other thing you could do if you really, really wanted to, is you could, with the intermediate, right, kind of like do a full chain cert where you have one appended after the other. But if you have both a root and intermediate predefined, then you'll have the full chain of trust. All right. Questions on that one? This is super valuable when you have a need for HTTPS, and you have a root, internal root cert, but you don't have internal ACME, which is pretty rare, I think, still these days. To ACME, automatic certificate management environment, which is what Let's Encrypt is built on. It's pretty rare to have that service set up internally. It's cool when you do, but most of the time, most organizations still have a pretty manual process when it comes to obtaining properly signed certificates with an internal root CA. That's been my experience. If other folks have different mileage, please say so. But as far as I know, it's pretty exotic to have that fully set up. Okay. And then even if you do Control C, Podman compose down to kill the containers, because the bunch of the stuff is still up, including the network. The dash T0 is just to say don't wait for a timeout, just kill it now. All right, moving on. We're whipping through these. Number 3, an ACME server. This one's a little bit more complicated. So this is where it turns out Caddy can be your ACME server. When I was doing a bunch of this for the new version of the Home Lab Almanac, I knew that I wanted to have a proper certificate. I wanted to have a proper PKI in the environment. And the first thing that I looked at, this is just a little bit of, behind the scenes, was a tool called Small Step. And Small Step is rad. And if you're looking at a PKI solution, you may want to look at Small Step. It will handle the entire PKI pipeline, up to and including things like zero trust, but it'll also be your root and intermediate CAs. Like, it's very, very good at what it does and very easy to set up. And there's an open source Step CA server that has a lot of the features that you'd be looking for, as well as a CLI component to it. And this was where I first started my experiments with an internal PKI for the lab. Then I moved to Caddy, and then I later learned that it turns out that Caddy actually uses Small Steps CA internally. So if you're using Caddy as your ACME server, you're actually using Small Steps CA under the hood anyway. Pretty cool, right? Okay, so what ACME promises is let's encrypt in your house. So you can imagine an internal network that has a desire to have all of its new web assets come online with a properly signed certificate from its certificate authority. That's really appealing. It creates a trust chain. It guarantees that you don't have a bunch of self-signed certs, makes life really easy for a bunch of different things that expect signed certs, right? You're not doing curl-k to ignore the certificate validation. And as we move toward a more zero trust or mutual TLS sort of reality, that's going to become more important. You want to have those properly signed certs on both the client and the server. So we might as well build the infrastructure to do it now. Okay. The gotcha with this, as we'll see, is that you have to use proper, fully qualified domain names, or bad things will happen with your certificates. So we'll have to do a little bit of modification here to make this work locally. Let's take a look at what we have in demo 3. All right, so in this case, we have some new components. There is a client folder, which is literally just a container that I put together with curl and OpenSSL that we can attach into the environment so that we can have easy name resolution and investigate things. But if we look at the config, there's also 2 different folders. There's the ACME and the requester. So the ACME server is the one that will actually provide the certificates, and the requester is just a website that is requesting a certificate. So some of this should look familiar, right? The top part is very similar to what we had in the self-signed, where we're establishing a local certificate authority, and we're giving it the same root CA that we did before. But now we have this acme.caddy.demo, okay? And we're saying that its TLS configuration, same as we did before, is internal, and the CA of TTI, and the ACME server is going to be the certificate authority TTI. This is how you set it up so that the certificate authority server itself has assigned cert. Okay, this is for itself because it's going to be serving the ACME server over HTTPS. That seems a little bit circular, but it's how we need to do it so that it has a assigned cert itself. But now if we go to the requester, things look a little bit different. First of all, in the global options, we now have 2 different directives that we're setting up. The first is the ACME CA. Where are we looking for ACME? The default is let's encrypt, but you can change it, and this is how you change it. So it's going to be the host name or the FQDN where the ACME server resides, and then the spec for ACME says it's going to be /ACME/ the whatever the cert authority is /directory. So in our case, since we're using TTI as our directory, that's where it lives. And then we're also saying to Caddy, you can trust this ACME server with this root trust. And so this basically says this is how you establish trust with the ACME server. And notice that inside of my site, I don't have any other TLS configuration at all. The reason is that because I'm using HTTPS and a fully qualified domain name, I don't have to, because Caddy is automatically going to use ACME to request its certificate. The trick is that in all default mode, it would be looking at Let's Encrypt to do its ACME request. We have modified its endpoint, its destination for ACME, but it's still doing that. So I don't have to do anything additional for the site configuration. It's doing its thing. It's just pulling its cert from a different place. Questions so far? Because that was kind of a lot. Okay. Um, I'll make one note then, which is the way that this works, the way that it can work inside of the containers is I have made the container the services named their fully qualified domain names. What this does, right? acme.caddy.demo, requester.caddy.demo, what this does is it hijacks Podman or Docker's name resolution to work with a fully quote unquote fully qualified domain name. So Caddy can see and use fully qualified domain names, and it goes to the right container inside of the Compose network. If I didn't do this, I would have to mess with their hosts file and or mine. And then again, the third container is a client, which is going to live inside this same network. And we're going to be able to use that client to verify that the certificates look good. And so if you look at the client container file, it's literally just Alpine, and I installed CA certificates, bash curl, and OpenSSL. So I'm going to show you how to use the client. And this is kind of a mirror of what you would have to do for an internal PKI anyway. So let's get to it. We're going to podman compose up. And it's building the container for the clients. And then it brings all of the machines up. We do podman compose PS. We'll see that we have all three of them up. That looks good. But we're not done really because we have some work to do on the client. What does anybody know what the client doesn't have that it needs in order for this all to work the way that we want it to? It doesn't have Brumbo. Well, that is true. And over time, that will be a critical problem. Certainly a tech debt issue that they'll have to run into. It doesn't have the root CA. And I specifically didn't put it on there so you could see how to install the root CA. Here's how we do that. We're gonna run podman compose cp ca and then ca cert.pem, and we're gonna copy it. This is very strange, so bear with me. We're gonna copy it to what is it? And compose. I forget what the container name is. Caddy 3 client. We're gonna copy it to Caddy 3 client, and we're gonna put it in a very specific location. User local share CA certificates, and then we're gonna call it CA cert. This part's important. Pay attention. CRT. Okay, my head exploded when I realized this, but it's true. The way that update CA certificates works is that it requires a PEM encoded certificate, but with a .crt file extension in this folder. I don't know why, but it does. So we copy that file to that location. Oh, I forgot a word in the command. Podman not compose container. Podman container CP. There we go. Okay, now we can do, whoops. God, yes. I love Zillage. Okay, so now we're going to do podman container exec -it caddy3 client and fire up bin bash. All right, now we're inside of this container, and we're going to just run update CA certificates. Actually, no, before you do that, let's try this. We're going to ping uh, requester.caddy.demo. Okay, so check it out. Name resolution is working fine. If I curl https requester.caddy.demo at this very moment, nothing happens. HTTPS. I was like, what's happening? I was expecting an error. There we go. I get an error. Unable to get local issuer certificate, right? That is by design because we have not updated the CA certs. If we now run update CA certificates and try it again, we get a response because it trusts the root. The certificate, which we had, the intermediate certificate, was issued itself by the root. And so by trusting the root, we're trusting the intermediate. Yes, I'm backdooring a little bit of PKI learning into this one. Any questions so far? That distributing of the root certificate is one of the most critical components of an internal PKI, as well as good hygiene for managing your root, keeping it secure, making sure that you've got renewals and stuff set up, intermediates are configured correctly. But if you don't distribute that root cert, none of it works the way that you want it to. All right. I'll exit out and we'll do podman compose down dash T0. All right. One last one. Now, I'll admit that this one is a little bit of a work in progress. There are some parts of it that don't work yet, and I'm still puzzling over what I need to do to make it fully work. Oh, sorry. No, we have one that works fine before we get to the last one, which is the reverse proxy. So reverse proxies are wonderful tools. Load balancing. I'll talk about what I mean by WireGuard in a second. And then, of course, containers. And then maybe something easier. Imagine you have a legacy application that only supports TLS1 or doesn't support HTTPS at all. I can tell you that in my, but I can tell you that in my universe, that's not that uncommon. Healthcare applications are long in the tooth, and very frequently you'll have some Java web app that was written a decade ago. The company went out of business and we're still running it, and it's mission critical for some lab, and what are you going to do about it? The answer is put it behind a reverse proxy that provides the security for you. Now, at least this layer of security, right? And this is really the baseline. What we're talking about here is getting away from compliance problems, right? Nobody is exploiting a TLS attack, but it's noise in the vulnerability management space in your environment, and you don't need to have it because Caddy makes it super easy to put a reverse proxy in front of those kinds of services with your proper cert and modern cryptography. And it's this easy. It literally is whatever your site config is, reverse proxy, and then your upstream. There's more you can do, but that's the default, right? And it's that's it. That's it. There's a lot under the hood that it does by default for you for that, but in terms of your configuration, not a whole lot to do. So I can tell you that one of the ways in which I use this feature is as a front for a bunch of services that are accessible via the web, but are hosted on my home lab. So I have a DMZ in my home lab. It can't touch anything else in my network. But each of the entities in that DMZ have a WireGuard connection out to a server on the internet. And that server on the internet is just a Caddy server that has a few reverse proxy configs. And the upstream for each of those sites is a WireGuard peer. So it's like a WireGuard address. And so whenever it receives a request for whatever site.com, it'll pass that right along the WireGuard tunnel, no problems. The DMZ server responds appropriately and sends the traffic back over the WireGuard interface. My stuff lives in my house, but it gets out to the internet, and I've got a fully secure connection from start to finish. And that's all negotiated through the reverse proxy config in Caddy. Really, really easy. If you want to get into self-hosting, it's a super simple way to get started. Okay, let's see how that looks. All right, so for this one, we don't need a client anymore, but let's look at our config. We have a proxy and a target. So if we look at the proxies Caddy file, it's again just this. And we're using the host name, or the container name, I should say, as our host name here for proxy target. And it's again localhost. And then if we look at the target Caddy file, we're back to straight up HTTP web server. So it's on port 80, but that's not what we'll see, right? We bring this up and we go to localhost 8443 and we see hello from behind a proxy. So it works okay, but the traffic is the web host is actually the insecure HTTP server fronted by our reverse proxy. Not hard at all to get started with that one. All right. We have one more. Any questions, really, at all, before we go into our final one? Okay. This one is a personal favorite. I have used Evil Gen X a lot for red team engagements, for demos, phishing trainings, things like that. And it works great, but it is kind of a lot of setup. And sometimes, depending on the kind of site that you're looking at, you don't need that much. So what this is kind of, as I said, a work in progress, and it's a way to use Caddy to approximate a bunch of the evil done by Evil Gen X. So it's not perfect, but it captures passwords just fine. And if there's no MFA, I've found it'll capture session tokens as well. MFA I'm still working on because there are a few things with MFA endpoints that get a little bit funky. But and I may need to create a custom module for that to work to like rewrite request bodies. I'm not quite sure on that one just yet, but I'm working on it. And then the other thing we're going to demo here is log filtering. As you may have seen, the logs for some of this are very noisy. And it's all JSON, the Caddy logs. So tools like JQ can really become valuable for making sense of what you're taking a look at. Let's take a look at our evil proxy and see what's going on here. There's only one container in this, which is the proxy, because we're going to be proxying GitHub, actually. Don't worry, you're not going to end up seeing my password, okay? Let's take a look at the Caddyfile config. As you can see, there's a whole lot more to this one. Global config, we have set up servers and log credentials. What this does, by default, Caddy's logs will redact anything that looks sensitive, including passwords and session cookies. I don't want it to do that, so I turn this off, or I enable log credentials. Again, I'm setting up an issuer internal for the self-signed cert. I'm telling it not to go for evilproxy.com. but I actually do need it to be an evilproxy.com. That's important because of the way that the reverse proxy works. What that means is that for this one, if you want to use this, we're going to have to add an entry to your Etsy hosts file on your machine for evilproxy.com just to be localhost. Okay. Inside of reverse proxy, you can see I'm reverse proxying github.com, and I am futzing with the headers. Header up is the inside of reverse proxy config to say add a header on the outbound. There's also header down. Header down will add a header on the response coming back from the reverse proxy. So you can do that as well. And then you can see that what we're creating a variable called rec body, and we're setting it to the value of whatever's in the HTTP request body, and we're appending that to the log, which doesn't contain it by default. And then I am making some changes to the default log with this format filter. And basically I'm saying, get rid of the level of the log, get rid of the logger file. I'm making it just a little bit cleaner for me to read the stuff that I care about from like a red teamer perspective. Like I want to get at the contents of the request, and this is how I do it. And I'm outputting it to var log caddy.json. All right, let's bring this one up. And I'm going to bring this one up raw so you can see the server do its thing. Okay, and then I'm going to create a new window here. And go to, oh, right, before I do that, whoops, I forgot the thing I said we have to do. We have to mess with Etsy hosts. And we have to add inside of the localhost, we have to just add an entry for evilproxy.com. And then evilproxy.com, 8443, because that's the port we're using. We haven't trusted Caddy's certificate, which is why we're seeing this. Hey, look, it's GitHub. And let me go to sign in. I'm going to sign in with Foobar and Foobaz. It's not going to be a real sign in, but enough that we can see how this works. And then over in my evil proxy, what you'll see is we're going to do podman container exec caddy5 proxy, and we're going to do cat var log caddy.json, and we're going to pipe that to jq dot rec body, and then we're going to grep that for password. Kaboom! So my reverse proxy captured the form submission and sent it to GitHub just fine. So what this means is, this is how EvilGenX works on the front end. So what this means is, imagine that I set up like a GitHab or whatever, right? Like some typo squatting, and I used this, right? And it's on the internet. It's got a Let's Encrypt cert, and I use that as my fish, right? The user's going to see GitHub, and it'll have a signed cert. Okay. It will be forwarding its traffic to GitHub, but on the way, it's going to be capturing the credentials. Now, as I said, MFA is a little bit weird. And there's like another request pipeline that I'm not into, like whether it's header based or something else that I haven't quite figured out, that if you have MFA, this part breaks, and it's what EvilGenX can do. And I'm still working on sorting that out. But I don't think it's impossible. And anything that doesn't have that pipeline, you're golden, right? And in addition, on the response, it will capture the session cookie, meaning you don't even need the password. You can just perform session hijacking because the cookies will be inside of the Caddy logs as well. So there you go. EvilGenX without EvilGenX. just with Caddy log configurations. So as you can see, Caddy is like the Swiss Army knife or the Leatherman of HTTP servers. I love using it. It's super flexible. It has fully replaced Nginx for all of my HTTP server needs. I'll deploy it wherever I can because of its ease of configuration and its capacity and its performance. Right? I mean, yes, Nginx is in C and Go is Go, but honestly, Caddy's performance is rock solid. I've never had a problem with it at all. That level you'll probably need Evil Gen X Pro. No, Dr. Lennon, that's not true. I can do this with just regular Evil Gen X. I have done it with regular Evil Gen X without paying for Pro. The trick is the way that Evil Gen X modifies, I believe, the response coming back so that or the request going out to make sure that things are going to the right location. I believe it's the callback URL for the MFA request, and that's the part I still have to sort out. What's the protection against it? The same site flag for cookie? Nope. Because uh, the cookie is sorted through the proxy anyway. Set cookie is being set that way. Um, the the defense against this is domain awareness. That is the defense against this. Oh, and there's one other cool trick, which is that if you have a password manager, right, that is gonna prompt you to autofill inside of sites, it should be a signal to you that it doesn't do that on one of these sites because the domain won't be right. Right, the password manager won't recognize the domain, the password won't fill in. So if you're using a password manager to actually prompt you to autofill your creds, that is actually a defense against this because it will not do so on a spoofed domain or a typo squatted domain. Okay, so that's going to be it for our Caddy intro. This will, of course, be on YouTube. Thank you so much for attending. And big thank you, especially to all the TTI members who provide material support for TTI and everybody who has purchased a course or for the book. It's incredibly appreciated. Like I said, there's going to be more of this in the not too distant future. I'm really trying to commit to doing more stuff like this. So thank you, and I hope to see you again soon. And as always, be good to yourselves, be good to each other, and happy hacking.